our second speaker of the evening, Professor Jantien Stoter. Jantien is Professor of 3D Information with a background in data science. She's the leader of the 3D Special Interest Group of the European Spatial Data Research Commission and the Vice Chair of the Open Geospatial Consortium 3D Working Group. As a data scientist, Jantien has a unique perspective on the topic of big data and architecture. Her research involves using 3D modeling techniques to integrate spatial information in different disciplines. As the only non-architectural researcher on the panel, I really look forward to your unique view on the topic.
Thank you very much for this introduction. First about the techniques, does it work? Yeah, okay. So my name is Jantien Stoter, and I've tried to answer the question, how will data technology shape architecture in the 21st century? And indeed, I'm a data scientist, and I'm in design illiterate, so I'm already sorry for now if I will be a bit blunt about some statements about architecture and design. First, I would like to start with a movie from the city of The Hague, in which they show their vision on how they would like to use a digital 3D model and data about the physical environment in the urban design process. It's a Dutch movie, but it's, the subtitles are automatically translated in the subtitles, so a few minutes later we'll come back.
Vooruitlopend op het invoeren van de omgevingswet in 2018 denkt men bij de gemeente Den Haag na over hoe dit visueel is vorm te geven. Het is technisch mogelijk om een driedimensionaal model te ontwikkelen op basis van alle door de overheid samengebrachte informatie en voorzieningen over een locatie, het zogenaamde digitaal stelsel. Met zo'n 3D-model wordt het voor zowel burgers als overheden een stuk eenvoudiger om alle ingrepen in de fysieke leefomgeving te beoordelen. Wim wil bijvoorbeeld als initiatiefnemer een nieuw gebouw voor zijn bedrijf neerzetten. Van zijn architect heeft hij een digitaal bouwplan gekregen. En nu wil hij weten of dit volgens het 3D-omgevingsplan op een specifieke locatie mag en kan. Via een plattegrond zoekt Wim eerst de locatie van zijn bedrijf op. Voor het tonen van de 3D-maquette worden gegevens over verkeersintensiteit, gebouwen, bomen, geluideisen en luchtkwaliteit real-time ingeladen en verwerkt tot informatie die nodig is voor het tonen van de 3D-maquette van de gemeente Den Haag, het omgevingsplan en alle beleidsaspecten die de gemeente heeft vastgelegd over het fysieke domein. Vervolgens laat Wim het digitaal ontwerp van zijn nieuwe bedrijfsgebouw. Het model berekent vliegensvlug of Wims bouwplan voldoet aan alle criteria die gelden voor deze locatie. Wim ziet onmiddellijk dat het bouwplan geen probleem heeft met de geluidshinder, omdat het gebouw buiten de rode zone staat. De rode zone geeft in kleurgradaties aan wat de geluidsbelasting van de weg is. Wel is er een probleem met de bezonning. Het gebouw neemt te veel zonlicht weg voor de naastgelegen woningen. Er is ook nog een probleem met de leefbaarheid. Het omgevingsplan eist een bepaalde verhouding tussen bebouwing en groen. Het 3D-model berekent dit. 2 dagen later. De architect heeft het plan aangepast en een deel van het gebouw lager gemaakt. Nu is er geen probleem meer met de bezonning, maar wel nog met de leefbaarheid. Dit knelpunt kan Wim door compensatiemaatregelen ondervangen. Er zijn nu geen problemen meer. Het bouwplan voldoet aan alle voorwaarden zoals die zijn opgenomen in het omgevingsplan. Hij verzendt het naar de gemeente voor een omgevingsvergunning. Piet bekijkt het bouwplan en ziet ook dat het past in het omgevingsplan. Piet beschikt immers over dezelfde informatie als Wim. Nadat het ook getoetst is op bouwbesluit en welstandscriteria, kan hij een omgevingsvergunning afgeven. Dit is een vereenvoudigde weergave van hoe een driedimensionaal model kan werken. De opgave is om op deze wijze de thema's van de omgevingswet in het omgevingsplan te verwerken. Maar technisch zal dit over een aantal jaren zeker mogelijk zijn.
So this is looks rather simple, such a process, but it shows how a digital 3D model and how data can be used in the urban design process, and it also questions what the role of an urban designer is in this new context of 3D data, and also models, simulation models that are available for any profession. If we look a bit further ahead, and we see how artificial intelligence can support the design process, then yeah, we can come with this idea. So with artificial intelligence, we can train a computer to classify objects in images based on thousands of examples. For example, we can give a computer thousands of pictures of a cat and thousands of pictures of a dog. And then the computer can train itself to recognize in the picture whether it's a dog or a cat. So similar, we could train the computer with thousands of optimal designs that have been designed by architects, so there's a lot of knowledge in these designs, and then let the computer decide what the optimal design is given specific requirements. So then a client could have an app to which he or she can tell the type of building that he or she would like, the size of the building, the budget that he or she has, the location, and then the app can offer in a few seconds a few options to the client, together with contact details of the local contractor who can build the building. So in this example, we can even question if you would need architects. And there's also an architect that that I found on the social media, and he indeed says that the rise of artificial intelligence means that the architects are doomed. So these are not my words. I'm citing someone. But in this blog, he says that it's important that architects are warned as soon as possible that 90% of their jobs are at risk, and that it's almost impossible for you to compete with algorithms. Well, I would say that it will not be that bad for you, for your futures, because it is not that straightforward. So, for example, with a deck, whether an object is a dog or a cat is, well, it's more or less a Boolean question, so it's a concrete question. But to decide what an optimal design is not trivial to classify. So what an optimal design is very subjective, but is also dependent on many variables. But also, we still don't know what the physical task of a design is that is relevant, that we can use to train a computer, and also how a computer could recognize the optimal design. So there are still some challenges to address before we can train a computer to make autonomous decisions from unstructured, uncertain, unsubjective data. So this will not be solved by tomorrow. So maybe we should look a bit more on the short term. So how can current data technology already change the profession of architects and designers? And then I would like to start with my own research. What we do in my research group is firstly we develop algorithms to automatically reconstruct 3D models of the physical world from all kinds of data that's available. So we develop algorithms to reconstruct 3D buildings, for example. And we have done this for all the 10 million buildings in the Netherlands. And those objects can be used in urban applications, in simulations, like daylight performance simulations, energy consumption simulations, wind conform simulation, noise simulations. And it's important to understand that that is more than visualization. So it's actually about the data beyond the visualizations, because you can also assign all kinds of attributes to those objects that are needed in the simulations. So in the next step, you can put your design in this geographical context and study the impact of your design on the geographical context and also the other way around. So you can study what the impact is of your design for wind and for daylight performance. And then that makes it possible to avoid, for example, a situation that we have here on the campus with the faculty of the computer science, because the wind situation is not very optimal there. So as you can also see in this movie, when it storms, then it's very hard to cycle over the road near that faculty. And with the simulations, you can predict such kinds of situations, and therefore you can adapt the design to avoid such situations. In this way, you can also use the design, so the digital design, in a digital building permit workflow, as was also proposed by the City of The Hague. Another example of a better design by 3D digital environments is here, and I've taken this from a national newspaper in the Netherlands. The picture that you see here is from a very nice city in the Netherlands. The name of the city is Deventer. It is almost as nice as Delft. And the city of Deventer wanted to locate 2 new wind turbines. And they hired a landscape architect to help them guiding this process with the citizens. And this landscape architect office, they photoshopped this picture that you see here. And you see here 2 wind turbines, and this was shown to the citizens. And also this picture was involved, was used in the decision process with the citizens. But then, after the wind turbines were built, the situation looks like this. So you have to look very careful to even see the wind turbines. So one you see more or less, but one is hidden. So it's clear that they used much too large objects in the photoshopped picture. And this is where a 3D model also can help. So in a 3D interactive environment, you can change the view of the citizens. So you can give them different views of the citizens to see how the windmills, the wind turbines are visible. But at the same time, you can experiment with different types of windmills, different heights of windmills, and you can also calculate the impact of the windmills on the noise and on the shadow that it produces. And this is also what you can show directly to the citizens. So this gives a much broader picture to the citizens to decide what the best location is of the wind turbines. So the examples that I've shown so far is about how data can support the profession of architects. But there's also potentials the other way around, how your digital designs can be very helpful in processes of others. So for example, if a construction is being built or an infrastructure has been built, and after it's finished, then the digital design can be used in the asset management of the construction. Another possibility is to use the digital design to derive the property spaces from the design, and this is what we did with the architect Meccano, who designed the station here in Delft. And in the station there are all kinds of property on top of each other, and this was very hard to visualize in the 2D cadastral map. So we used the digital design and we transferred that into property volumes, and these are now registered in the Cadastre. And another use of the data is by registering a passport for every building. That's also something that the Cadastre is currently working on in the Netherlands, so that you know the materials that are in the buildings. If you want to renovate the building in 10 years, this information is very helpful in circulating the materials that are in the building. What is useful to note here is the different cultures, the different data cultures in the domain that I'm active in, and I suppose the domain that you're active in. Because so I'm active in the domain of Geo-information, and that is a government environment, which means that sharing data is a very important ambition. So we have standards, we have lots of open data available, but I am aware that in your domains it is much harder because there's authorship in the designs, and you maybe not want to share all the data that you've designed. So this is also something to think about. Then the next question is, what should architects know about data when they will use the data in their profession? And I think there's lots of things to know about the data and how to use them, but I would like to highlight one thing to illustrate that it's important to understand the impact that data may have if you are using it. So the thing that I would like to highlight is data is not reality, and often this is in misunderstandings. People assume that what is in the data is also according to reality. So the data that we work with, it has a temporal accuracy. It is collected at a certain scale and a certain level of detail. So this means that you have to understand that this accuracy has an impact on the analysis that you perform with the data. But also it's very important to be aware that models and data that are input for those models are always simplifications of reality. So models are never a one-to-one representation of reality. So the models are meant to understand and predict specific urban processes. So they are a selected view on the reality. That means that they also do not represent the whole reality, and that choices are being made to collect specific objects or to collect specific details. So for example, in wind simulation, you don't need to have the roof shapes of the buildings, and even they should be avoided because the wind simulations are very computer intensive. So it is better to have simplified buildings in the wind simulations. But if you want to do an analysis on the solar panel potentials, then you do need those geometrical details. And also, if you have looked at the model of The Hague, then you also see major simplifications that have been made in the model. Like, for example, what I show here on the slide, it's how The Hague represents its noise levels, and of course, this is also a simplification, and this has an impact on the results. So data and models are a selection of reality, and every domain has its own view on reality and its own model on reality. So this can result in the situation that there are different views of the same reality that can both be true but do not represent the whole reality. So for example, that the person in this cartoon, one person sees 3 beams, another person sees 4 beams. They're looking at the same reality, but they have different perspectives that might look contradictory. And I'm not sure if you have ever heard about the term digital twin, but it's also something that is very often mentioned when we talk about big data and about representations of reality. So in my view, there's also not one digital twin, because depending on the application, you have a specific representation of reality. Well, to make this a bit more concrete, let's look at a model of a house. So in a geographical context, where we model cities and also complete countries, a house is one object, and it's modeled via the measurable and the observable surfaces. And this is also what is needed to be able to perform analysis with the model. Also, the model should be watertight to do, for example, a volume calculation. In the building information modeling domain, so that is where the data is designed for the construction, a house contains a collection of mostly over 1,000 elements that represent structural components of the house, and they're mostly modeled as volumes. So as a human, you might think, okay, this is the same house, who cares? But if you would like to use the design in a geographical context, we need to convert one model into another so that the computer also understands these kinds of concepts. And this is not very trivial to do this in an automated manner. And there are many papers written on this specific problem. So another question that I also asked myself when I prepared this presentation is, what about the creativity that an architect can put into a sketch or an analog design? Because I see how important this is in your profession. And so I dared to also answer this question. But I put on the slide for discussion. So what I think is that this question might get less relevant with the new generation of architects. If I look at my own profession, of my own domain also, 20 years ago I started with the research on 3D. And then it was also a huge question how people would understand the 3D models, because they were only used to understand maps, to understand reality via paper maps. But now this question is not relevant in my domain anymore, because we see generations that were brought up with 3D models, 3D television, 3D in gaming. So maybe the current generation of architects, the students, can be more creative with digital tools than established, I didn't want to mention senior architects and data scientists. So there's a question that I think is relevant for the students also to answer. But besides that, creativity is still required in a digital approach, because you still need to make decisions based on for example, the options that a computer will give you. So to conclude, how will data technologies shape architecture in the 21st century? So first, I would like to come back to the question if architects will be redundant with AI, become redundant with AI and computers and big data. Well, I don't think so. So computers may be able to calculate optimal designs in the near future, but open-ended solutions that the computers will provide us they still reserved, there's still need designers and architects to make decisions on. But what will change, and it's already current reality, so relevant for the current students, is that through automation, architects may be relieved from basic design tasks, and they may also be able to build on available knowledge that is embedded in data, so they might have more time for the actual design process. And also, with the integration of the design into its geographical context, the impact of the design on the environment may be directly visible, and therefore the designs can be adjusted during the design phase, and it's maybe better. This gives better possibilities to fit it to future urban challenges, and also balancing between different kinds of factors like noise and daylight performance and wind comfort. And another thing that I wanted to highlight is that again, architects are parts of the data and an information society. So it's not only that that we should ask the question, how will the profession of architects change with the availability of big data, but also they are part of this information society. So they're not only consumers, but also suppliers. So what does this require? So I think for architects, it requires understanding and using the potentials of data and tools, but also understanding limitations. It also requires coding and data skills to understand the techniques behind such applications that I've shown to you. Also, it's needed to rethink the authorship and the copyrights. So what kind of data do you want to share with the outer world and what not? We also need standards to use data from each other's domains. And finally, for the artificial intelligence, we need to understand how we can train computers to make design decisions based on unstructured data and subjective labels. This means for you, I don't know, but I thought maybe I can end with suggestions for the announcements that you do for the INDESEM 2021, because there it says that you want to explore data-driven architecture. And I think it should be data-supported architecture, because data-driven architecture means that the data is in charge, and I think as an architect you should be in charge and use the data to support you. And also maybe you could consider to add the data supplying part of an architecture. Thank you very much.